Hello everyone from the world of industrial automation. The main goal of this channel is to teach you how to work with CODESYS using real-world examples of automated control systems, not with a virtual PLC, but with an actual controller and other industrial equipment from akYtec. Let's develop an automated control system for an industrial dry heat sterilizer, which is used to disinfect metal instruments, for example, in the medical or beauty industries. Web visualization allows you to control the automated system from any device with a browser, including your smartphone. All the mentioned devices are connected to each other through a router that has internet access. And this will allow us to demonstrate how web visualization works, as well as connect the SPC210 controller to the akYtec cloud service. This template developed by akYtec frees the user from needing to know what Modbus is. That is, you don't have to spend time studying documentation, the module's register map, or worry about how to properly configure numerous parameters for forming requests, or rearrange registers to get correct data and convert them to the required types. Did you notice that my voice changed? The thing is, I want to find the optimal voice for you using AI. Please write in the comments which voice you like the most and which one you think is my real voice. The first condition is converting milliamps to degrees Celsius. But this block of code is commented out, since the analog input module from akYtec handles this task for us. The next block of conditions is about improving our prototype. In the event that the current temperature happens to exceed the maximum temperature limit set at 190 degrees, we will immediately turn off the heating element and switch the sterilizer over to cooling mode. We also set the alarm variable to true, which we then send directly to the akYtec service. Please make sure to write a detailed explanation in the comments section regarding why this improvement is needed and why we send this alarm to the cloud, focusing especially on the specific details regarding the access type. Read and write. The first component is a rectangle. To enter new values, let's set up a click event handler and select the function to handle this event, writing to a variable. In the input type field, select the Visu dialog's numpad dialog, or simply put, the digital keypad window. Set the minimum value field to 0, so the user can't enter a negative value. In the next video, we'll answer the question of how we ended up in the middle of the CODESYS project. And for that, we'll go back to the very beginning. We'll also start analyzing the CODESYS simulator project, which we'll need to improve the sterilizer prototype. And we'll also launch the surprise segment, where we'll cover a topic that wasn't announced in the previous video. Write in the comments what you would like to see in the surprise segment. And who knows, maybe we'll cover your topic. How did we end up in the middle of the CODESYS project? To answer this question, let's go back to the very beginning. The first step is to download the necessary software. To do this, let's go to the akYtec company website. In the Products section, select Programmable Logic Controllers and choose the SPC210 Touch Panel Controller. Then, go to the Documentation tab and Software. Next, download the installation file for the CODESYS development environment. CODESYS 3, 5, 17, 30 IDE 32-bit. Then, download the installation file for CODESYS target file. For integrating the SPC210 controller into the CODESYS environment. After that, download the installation file for CODESYS templates to integrate MX210 series input-output modules into the CODESYS environment. The second step is to install the CODESYS development environment. To do this, simply run the installation file, and during the process, Application Installation, leave all settings at their default values. Just click the Next button each time. The third step is to install the target support file for SPC210 in the CODESYS environment, the so-called target file. To do this, open CODESYS and in the Tools menu, select the item CODESYS Installer. And after that, be sure to close the installation environment while the package is being installed. In the CODESYS installer, click the Install File button and select the installation file akYtec Targets Package. During the file installation process, just click the Next button. If you haven't closed the CODESYS environment by this point, the CODESYS installer will ask you to do so. Similarly, install the akYtec MX210 templates package to support MX210 modules in the CODESYS environment. Step 4. Open the CODESYS environment and create a project from scratch, just like in our first video. Select the SPC210 modification. Next, delete the unnecessary device in our project using the delete command. Add the Modbus component to the Ethernet device. TCP master from CODESYS. And then, you should incorporate and include the specific polling data templates for the various modules from akYtec into the existing system. Then proceed to add the specific text list, which is titled Manual Relay Select List. To configure the main relay selection mode, enter the corresponding values in the ID and default columns, as you saw in the second video. Step 5. Click on Visualization in the device tree, and you'll automatically go to the Visualization Editor, where, for the sterilizer settings, we add the required number of rounded rectangles to the screen. Next, add the COBOBox integer component and in its settings, specify the text list we created. Then add the power switch and lamp components. And finally, add the bar display component. We skipped these 5 steps in our very first video, and as a result, in the middle of our CODESYS project. Let me know in the comments what I forgot to add to the device tree compared to the project from the first video. Let's move on to reviewing the Industrial Sterilizer emulator, which will simulate the temperature change process according to the specified settings. We'll demonstrate how it works in action. To do this, let's set the heating rate. 0.15 degrees Celsius per second, which equals 9 degrees Celsius per minute. And the cooling rate is minus 0.02 degrees Celsius per second, which equals minus 1.2 degrees Celsius per minute. Now, let's switch to the visualization of our main project. Press the power button and watch the temperature change process in the emulator. As you can see, the emulator changes the temperature according to the specified settings. Let me know in the comments what other settings you would add it to the emulator project, because it's obvious that a sterilizer has characteristics like heater power, tank volume, and thermal insulation. And depending on the sterilizer model, all the characteristics I mentioned can be completely different. Now let's move on to the surprise section and show why the visual components of the emulator project are different from those in our main project. To do this, let's go to the Visualization Manager, and let's change the selected style setting to default. Now let's go back to the Visualization Editor, and as we can see, now the visual display of our components is updated accordingly. It is the same as in our main project. Let us know in the comments which visualization style you like more. Now let's answer the question from the previous video. Why, when the temperature exceeds 190 degrees Celsius, do we turn off the heater and we switch the sterilizer to cooling mode, as well as set the alarm and send it to the cloud service of the akYtec company in read-write mode? The thing is, with prolonged exposure to temperatures above 200 degrees Celsius, the cutting edges of metal instruments can lose their sharpness, as well as cause a loss of hardness and strength in the metal, and a change in its color. As for the sterilizer itself, this can lead to deformation of the metal walls, damage to the heating elements, and to the thermal insulation. We send this alarm to the cloud service of akYtec in read-write mode, so that only the operator can reset this alarm after analyzing the abnormal situation and making corrections, the causes of the sterilizer malfunction. When this alarm is reset, a record remains in the cloud service history with a timestamp of the alarm reset and the name of the responsible operator who performed this operation. And, obviously, we need to fix the flaw in our sterilizer algorithm. And when manually pressing down on the main start button for the sterilizer, we also need to carefully check to see if this specific alarm is active. It is only in the case where this alarm remains false that we will then proceed with the next steps. Switch the sterilizer to the heating state. In the next video, we'll take a detailed look at the emulator algorithm code in ST language, and also explain how to set up data transfer between the main project and the emulator project. For now, I suggest you find any shortcomings you've noticed and propose ways to solve them. We are also looking forward to your suggestions for improving the sterilizer algorithm. For example, you might suggest replacing the temperature control method with a more precise one, such as PID control. I also suggest the following topics for training videos, which I've pinned on the channel, for you to choose from. How can you use the built-in OPC UA protocol server in CODESYS to integrate the SPC210 into popular automation platforms from well-known companies? How can you use the built-in cybersecurity tools in the SPC210 to protect against hacker attacks? How can you increase the response speed of the SPC210 in CODESYS? And of the input-output modules polled via the Modbus TCP and Modbus RTU protocols. What are the advantages and disadvantages of the modes Modbus Master and Slave on the Weintek operator panel when used together with the SPC210? What are the advantages and disadvantages of multitasking in CODESYS? How can you use the visualization editor in CODESYS to create a multilingual project and set up screen navigation? How can you use the built-in library in CODESYS? By calling Linux utilities, integrate the SPC210 with popular automation platforms from well-known companies or with any specialized applications in general. How can you use the built-in akYtec communication library in CODESYS to bypass the limitations of standard Modbus components? Let us know in the comments which topic interests you most from the ones suggested, or suggest your own. Also, if you want to learn CODESYS using real industrial equipment, our channel has the unique right to provide a promo code for a 35% discount on the purchase of the SPC210 and input-output modules from akYtec. To get this promo code, just follow the link below to our WhatsApp or Telegram channel. In the channel profile, you'll find my personal contact. Send me a direct message with the word promo code. But I want to point out that this promo code is only valid for 24 hours, so please contact me only if you have already added. the products to your cart on the akYtec website. And one more nice surprise for those viewers who buy the SPC210 and send me in a private message. The serial number of their controller. I will provide all the CODESYS projects used in the channel's videos for free. You can also subscribe to our WhatsApp and Telegram channels so you don't miss announcements for upcoming videos. And of course, so you can always get a promo code for a discount on akYtec products. And don't forget to subscribe to our YouTube channel so you don't miss future videos. And give this video a like if you enjoyed it. That's all for now. See you in the next videos.